An Introduction to Quadratics. Factorizing quadratics. There are three types of factorizing. You've got this example here where you have all three terms present, and then you've got these where one of the terms is missing. So in this one here, the constant at the end is missing. In this one here, the linear term, the x term, is missing. And the method used to factorize each of these is different. Let's look at factorizing quadratics that only have two terms. In this one, the constant is missing. To factorize this, if I take x out from both of these terms, that sign in the middle is a minus, that goes there. So x times x would give me x squared, and x times minus 3 will give me minus 3x. That's now fully factorized. Once you've factorized, you can multiply the brackets out just to test to see if your factorization is correct. So x times x is x squared, x times the minus 3 gives you minus 3x, which is the same as what you started with. So you know this is correct. Factorizing 4x squared plus 8x. So if I was to take the x out this time, that would leave 4x plus 8 inside the bracket. But this is wrong because it's not fully factorized. To fully factorize it, I should take 4 out from each of these two as well. So I should have taken 4x out to begin with. That's a plus. So 4x times x will give you 4x squared, and 4x times 2 will give you 8x. So that's now fully factorized. In this example, I can only take out x from both of these terms. So then I've got 9x here, so x times 9x will give me 9x squared, and x times 2 will give 2x. In this example, I'm going to take minus 2x out. So minus 2x times x will give me minus 2x squared. Now I need to be careful with the sign here because that's negative, that's positive. So this times something negative here, so a minus times a minus will give me a plus. So this has to be negative. So 2 times 3 will give 6. So minus 2x times minus 3 will give plus 6x. Factorizing two-term quadratics, where you only have the x squared term and the constant. And the constant is some square number. To factorize x squared minus 25, we should first look at the difference of two squares and what this means. Now let's say if you have a plus b times, and the same terms again, but with the opposite sign. So you've got a plus in one of the brackets here and a minus in the other one. If I multiply out the brackets here, so a times a will give a squared, and then a times minus b will give me minus ab, and then b times a will give ba, or ab, it's the same thing, and b times minus b will give minus b squared. And as you can see, the minus ab and the plus ab terms cancel out, leaving you with a squared minus b squared. So you've got a squared term here, you've got a squared term here, and that minus in between is a difference, the difference between them. Hence, the difference of two squares. This is why I was saying that if you have a two-term quadratic like this, where you have the square term and a constant, as long as that constant is some squared term, you can very easily factorize this. So, factorizing x squared minus 25, let's start by writing it as x squared minus 5 squared. So 2 squared terms and a difference. So this is now represented as the difference of 2 squares. And this will factorize like this. And as you can see, you've got A and B in both of these brackets here, except that's got a plus, that's got a minus. And the A and the B are just these, which in this case would be x and the 5. That's your A, that's your B. So put the x here, put the 5 there, the x here, and the 5 here, and you know the signs are opposite. Doesn't matter which way around you put them. There you go, factorized, using the difference of 2 squares. Factorizing 3x squared minus 6 squared. So we have this term squared, and there's a minus in between. So we have the difference of 2 squares. So as before, take the 3x and the 6, put them like this. Then the signs have to be opposite, plus, minus. In this expression here, if we were to do this, thinking that this is the difference of 2 squares, and then factorizing like this is wrong. This term here, the whole term should be squared. Just like this. You had something in brackets with the square on the outside. And we should write this term in the same way. Something in brackets with the square on the outside. 4x squared should be rewritten as 2x in brackets squared. So now the whole term is squared. In this, only the x is squared, not the 4. But now both the 2 and the x, they're both squared. And 2x squared just gives you 4x squared. So these are the same. Minus 6 squared. So then you've got 2x plus 6 and 2x minus 6. 49 minus x squared. So 49 is 7 squared minus x squared. So we have the difference of 2 squared terms. So add them and subtract them. So factorizing 2-term quadratics, where you only have the square term and the constant, is simple because you can just use the difference of 2 squares. But one of the conditions is both terms must be squared to begin with. Factorizing 3-term quadratics. Well, there's 2 different types here. You've got this 3-term quadratic where the coefficient of x squared, so the number that x squared is multiplied by, is 1. So that has its own method, and that's simple. And then you've got those where the coefficient of x squared is not equal to 1. And this has its own method for factorizing, a slightly longer method than this. But they're not difficult, these are simple to factorize. In this section, I'm just going to assume that any example I give you will factorize. In reality, you could come across a 3-term quadratic that cannot be factorized. And whether something factorizes or not can be worked out. You can use something called the discriminant to decide whether something will factorize before you start. But in this section here, I'm going to assume that all of my examples will factorize. In this three-term quadratic expression, we're going to factorize. To get the x squared term, we need x in each of the brackets here, so x times x will give x squared. Now the number that goes here and here, so these two here, must multiply to give 6 and add to give 5. So 2 and 3, 2 times 3 will give 6, and 2 add 3 will give 5. So then the signs here should be positive, so that's fully factorized. Okay, in this example, again a three-term quadratic, the coefficient of x squared is 1. So this is an easy one to factorize. So you have x here and here. Now I'm looking for two numbers here that multiply to give minus 6, but add to give minus 1. So those two numbers would be 2 and 3. 2 times 3 can give 6, but I need minus 6, which means one of these should be negative. That's the negative one, that's the positive one. The reason it's in that order is because 2 times x will give 2x, and minus 3 times x will give minus 3x. 2x minus 3x gives minus x, this term. And 2 times minus 3 gives minus 6, this term. In this three-term quadratic expression, the coefficient of x squared is not equal to 1, so we use a different method in this one. Okay, start off by multiplying the coefficient of x squared with the constant. So 2 times minus 3 gives you minus 6. And then take the coefficient of x, which is minus 5, and write that underneath like this. Now I'm looking for two numbers that will multiply to give me minus 6, and I'm looking for two numbers, the same two numbers that you write here, that will add to give minus 5. Okay, so this is a standard part of this method, where you start off by multiplying the coefficient of x squared with the constant. So 2 times minus 3, write it like this, minus 6. So then we need two numbers that multiply to give you minus 6. And then take the coefficient of the x term and write it here. And those same two numbers that you're going to work out here should add to give you minus 5. Now numbers that multiply to give you 6, so just ignoring that sign for the time being, that multiply to give you 6. So 1 times 6, 2 times 3, and that's pretty much it. We're just looking at the various factors of 6. Now which of these can we use to get the minus 5 as well? Okay, so as an example, let's say if I try the 2 and the 3, like this. Now one of these has to be negative to give me minus 6. Okay, I'm just trying this, I'm not saying it's going to work. Right, so 2 times, let's say if that was minus 3, that would give you minus 6. So if that's minus, this has to be as well. But 2 add minus 3 doesn't give you minus 5. And neither does it work this way round. Minus 2 times 3 is minus 6, but minus 2 plus 3 doesn't give you minus 5. So this option here doesn't work. So the numbers I should be using are 1 and 6. These two. So 1 times minus 6 will give me minus 6, and 1 add minus 6 will give me minus 5. These numbers both work. So this 1 and this minus 6 are used to split up the x term. So the 1 gives 1x, and the minus 6 will give minus 6x, like this. So 1x minus 6x will give you minus 5x, so that works. And then just copying these terms down, so we had a 2x squared here, and we had a minus 3 there. the next stage involves taking the first two terms and fully factorizing them. I mean, looking at this, there's no reason to even put the 1 there, but I've left it there just so that you can see that 1 comes from here and that minus 6 comes from here. So factorizing these two terms, I can take x out from both of these. So fully factorizing will leave 2x plus 1. So x times 2x, 2x squared, x times 1, the 1x. Okay, once you've factorized the first two terms, copy this factor here in the brackets to the right hand side, and then work out what sign should be here and what number should be here. So we multiply this by what's inside the brackets here to get these two terms on the right hand side. So clearly there should be a 3 here, so 3 times 2 will give you 6, but that's a minus 6, so that should be minus. And minus 3 times 1 will give you minus 3. So we're almost there. So in both of these parts here, there's a 2x plus 1 here, and there's a 2x plus 1 here. So if I factorize by taking 2x plus 1 out, what's left over is the x here and the minus 3. And these two go in here. There you go, fully factorized. The only time-consuming part in this method is this stage here, where you have to work out what these numbers will be to multiply to give you this, or to add to give you this. The rest of it's straightforward. This is the time-consuming part here. Okay, another example. Again, the coefficient of x squared is not equal to 1. So we start off by multiplying the 10, the coefficient of x squared, with the constant. So 10 times minus 6 gives minus 60. So I need two numbers that will multiply to give me this. And the coefficient of x, which is minus 11, goes underneath. And these same two numbers should add to give minus 11. So what numbers multiply to give 60? So just ignoring that sign for the time being, what numbers multiply to give 60? Well, I could have 60 times 1. All of these numbers in pairs can multiply to give 60. But which of these pairs can also have a difference of 11? Well, 60 and 1 can't have a difference of 11, whether you do 60 minus 1 or minus 60 plus 1 or whatever. That's not going to work. Neither is this. 20 and 3, you can get 17 if you find the difference between them. That doesn't work. 15 and 4 can give you a difference of 11. So 15 minus 4 gives you 11. 12 and 5, nope, they don't work. 10 and 6 don't work either. So 15 and 4 are the numbers we need to use. Now we need to check the signs. There's a minus 11 here. So minus 15 plus 4 will give minus 11. I need the same numbers. So if that's minus 15, this should also be minus 15. Minus 15 times 4 will give minus 60. So these do work. Okay, let's use the minus 15 and the 4 to split up that central term there, the x term. So if I write this as minus 15x plus 4x. So there's the minus 15, and there's the 4. And minus 15x plus 4x does give you minus 11x. So we haven't actually changed anything, it's still the same. And then copying down the other two terms here, so we've got 10x squared, and there's a minus 6 here. And then as before, if we take the first two terms, the two terms on the left, and fully factorize them. So what can I take out from both of these? Well, there's a 10 and a 15 there, so we can take 5 out, and there's an x in each of them. So 5x times 2x will give 10x squared, and 5x times minus 3 will give minus 15x. And this factor here, copy to the right hand side, and then decide what number will go here. So if you multiply these, you get the terms on the right here. So we'll need a 2, that's a plus. So 2 times 2x gives you 4x, 2 times minus 3 will give you minus 6. And then last of all, from the first part here, the left-hand side, there's a 2x minus 3, there's a 2x minus 3 on the right-hand side. So we can factorize by taking that out. So what does that leave? It leaves the 5x and the plus 2, which goes here. There you go, fully factorized. So to summarize, we've had a look at how to factorize quadratics, and we looked at two-term quadratics, where the constant was missing, two-term quadratics, where the linear term, the x term, was missing, and then we've looked at three-term quadratics, where the coefficient of x squared is 1, and where the coefficient of x squared is not equal to 1. But these are all expressions. How would you factorize equations? So if these were all equations, first of all you make sure that all of your terms are on one side and you have 0 on the other side. So for instance, let's say from this example here, you started off with x squared plus 5x is equal to minus 6. You would take the minus 6 over, so you would have x squared plus 5x plus 6 is equal to 0, and then you would factorize. So make sure each one is equal to 0 first. Well, after that, the method is what you did before, absolutely no difference whatsoever. So the first one, we had x times x minus 3 is equal to 0. In this one here, we were using the difference of two squares, so we had x plus 5, x minus 5 is equal to 0. And in these three-term quadratic equations, factorizing as you did before. No difference here either. And to take each of these one step further, because these are equations, we're looking for solutions to the equation. So for what values of x here will all of this be equal to 0? So factorizing here, and then either x is equal to 0 there, or all of this, the x minus 3 is equal to 0, so x is equal to taking the 3 over 3, so you have two solutions here. In this one here, you've got x plus 5, make that equal to 0, so that factor equal to 0, so x is equal to minus 5, and do the same with this one, x minus 5, make all of that factor equal to 0, so x is equal to 5. So we have two solutions there. Because it's the same number but opposite signs, you can write it like this, x is equal to plus or minus 5. That incorporates both of these two. In this one here, this factor here, x plus 2 is equal to 0, x is equal to minus 2. In this one here, x plus 3 is equal to 0, so x is equal to minus 3. This one, 2x plus 1 equals 0, 2x is equal to minus 1, x is equal to minus a half. And from here, x minus 3 equals 0, so x is equal to 3. So once you have your factorized equation, your factorized quadratic equation, working out the actual roots or solutions is simple. You just make each part here that you factorized equal to 0, and then solve. Like 2x plus 1 there, make that equal to 0, and then solve what you have there. Very simple linear equations that need to be solved.